Hey everyone, my name is Mike, a power line technician for Fortis, Alberta. Today I'm here to talk to you about kind of the system that we have in place to bring power to your house, as well as some of the safety equipment that we use, and how I can actually work on this type of system safely. So part of, I guess, right off the hop, we got arc-rated clothing, high vis, we got orange, reflective stripes, pants, feet, back, arms. So part of the high vis is just for, we work around a lot of vehicles and kind of in and out of traffic, so this just prevents traffic from hitting us or being able to see us effectively. The orange is just another high visibility, but this clothing is actually rated for fire resistant or arc resistant, so if there is something that we're working on that does cause an arc or a flash, that this won't melt into my body. Another thing I guess we need before we go into the field is going to be a hard hat, and then safety glasses, and then gloves. Okay, so we're just going to cover some of the basics, how we bring power or electricity on our system up to your house. Part of it has to flow electrons through what's called a conductor. This is obviously a larger conductor than what you'd see in your residential service or even your iPhone cord. So we typically use aluminum, steel, or copper, which have a good conductivity, it's called, to allow passing of electrons through it. But even your little iPhone cord is going to have tiny little conductors in it. Another portion of our system, is insulation. So these, obviously, electrons are flowing through it. You have to isolate it so that it's not going to be able to make a hazard coming down to the ground. An insulator does that purpose. So on our system, we typically use form of plastic, rubber, glass, or porcelain. So how this kind of works, this is a very poor conductor. So even if you have electricity running on it, it's not going to allow the electrons to pass through it and go out of the insulator. So you'll see on our system, on overhead power lines underground, it's all going to have an insulator that's touching our high voltage conductors. Alright, so part of my job is going to be climbing power poles to be able to go and do maintenance up on the structures, or using a bucket truck. But for right now, I'm just going to set up my climbing gear, put it on. Give me 1 second. Done. Okay, so we'll go over some of the gear I just quickly put on. We got starting off on the feet. So these kind of allow me to climb the pole. I don't know if you can notice from there, but they got a big spike on the bottom of them that digs into the pole to allow me to climb like a bear up the tree. So these are called spurs. They're strapped to both feet. Then I got a belt that wraps around my whole body. So this just really secures me at one point. And then there's a body harness that's wrapped through it. So even if I fall off the pole, or if something happens where I get knocked to the side, that this body harness and this belt will actually keep me secured. This is what is actually securing you to the pole, cinching tight. And then as you climb, feet are stuck in with the spikes. Climb up the pole. Kind of like I said, even if you fall, the belt's going to keep you there. And so part of working on the power system is sometimes we have to actually de-energize it or turn the lights off per se. So we got, similar to your house, you have your light switches that turn the lights on and off, but on our system it's got switches that look like that up there. And to operate them we use insulated sticks. So we're going to have, this is called a telepole because it's telescopic and we can run it out. So bring it up to the line. This is all insulated so it protects me from touching the high voltage 14,000 volts up there. Lights off. Lights on. Lights off. Lights on. So working around electricity, part of my role as power line technician is be able to use safe work practices and the tools in order to actually energize 14,000 volts or higher power lines. Part of those tools are going to be insulated hot stick is one example. So this is fully tested and rated to be able to handle touching power lines while keeping my hands and body and everything at safe. Another tool is going to be an insulated telepole. So this here, part of what I told you about operating those switches safely. This part is insulated. No electricity can pass through it, so very minimal. Another one is going to be 30 kV rubber gloves, they're called. So part of that, good try. So this is insulated material as well. So the work that we do primarily with these is working on actually energized power lines, hands-on work. You can see they're rubber material, tested, rated, so that we can actually handle with our hands energized 14,000 volts. Looking at a power line doesn't look very hazardous, but there is very high voltage in that power line, and if you do touch it, or you do fall a tree onto it, or if you even have a ladder that for some reason goes onto it, there is very high danger to working around, especially overhead power line. Okay, so I just want to remind everybody that these green boxes that you see on the end of your driveways around town, there is danger to them. You can see this one in particular has 14,000 volts, so it is high danger. Please don't climb on them. Please stay safe. If you do notice any holes, like rust or something, or a door has been cracked open, or especially if there's a quad or something hit it, or a vehicle hit it, stay far back away from these and stay safe. Okay, we drive all types of trucks, ranging from a service truck, similar to what this would be. We got bucket trucks that take us up in the air to work a loft. We got digger trucks that are dig pole holes, they'll set poles, they'll grab street lights and set them on. So you'll see us all around your areas working. Don't be afraid to stop, say hi, ask us questions. Most importantly, be safe. Catch you next time.